Good morning or good afternoon, depending on where you are. I'm John Drayton. I'm Burns Engineering's National Lead for Zero Emission Mobility. Let me start by thanking you for joining us today. We'll be hearing from three industry veterans that have hands-on experience with hydrogen and fuel cell technology. We hope you'll find this discussion informative and maybe can help some of you who are fleet operators better understand some of the current trends in hydrogen technology and fueling options. Just looking forward, next month on Wednesday, May 24th, we're planning to host our second monthly webinar on P3 or public-private partnerships. We'll be looking at charging and fueling as a contracted service, and we plan to pull in industry leaders to talk about options for design, building, operating and maintaining fueling or charging systems for your fleet. So with today's panelists, let me go through first, and I'm really glad to see he's here, Cecil Blandon. He's the Director of Maintenance for AC Transit in Oakland. AC Transit has the largest and longest running fuel cell program in the US. And of recent note, AC Transit recently made a strategic decision that instead of building up a fleet that's 50-50 battery electric and fuel cell buses, they've gone to 70-30 in favor of fuel cell buses. So we'll certainly want to dig into that today. And when he's not overseeing AC Transit's fleet, Cecil keeps busy chasing his kids around who are top soccer players. Next, we'll be hearing from Harman Singh. Harman is Sunline Transit's Chief Performance Officer. Like with AC Transit, Sunline is a longtime leader in advanced vehicle technologies. What is interesting about Sunline is they operate on-site reformers for both electrolysis and steam methane reformation, and he'll talk about how they provide fuel for their fleet on-site. And just on the side, when Harman is not busy with their fleet, he's a cricket player, which I thought was very interesting. Next, we have Stacy Grauer, and Stacy is Director of Business Development for Linde, one of the world's leading suppliers of industrial gases, including hydrogen. And Stacy tells us when she's not busy supplying everyone with hydrogen, she's an active hiker and kayaker. And finally, our host or our MC for today, who recently joined Burns as our Senior Zero Emission Engineer, is Kate Shaner. Kate has a background evaluating hydrogen fuel opportunities for a variety of fleets. She's a mechanical engineer, and I've had the privilege of working with her over the last 5 years. And when Kate is not working, she's actually a professional sailor. And she competed in the 2020 Olympic trials. And we'll be watching when the Olympics come here to LA in 2028. We'll see if Kate can make it onto the team for that event. So with that, that's our panelists. I'm going to step back and let Kate run the show.
Thanks so much, John. We're going to be going through today asking a few topical questions to each of the panelists and keeping it kind of conversational. If you guys have any questions, feel free to type them into the chat box. We're going to reserve 15 minutes at the end to go through them. If you guys have the same ones, we'll kind of compile them all. Yeah, so feel free to type in any questions you guys have as we go. And with that, let's get started. So we're going to start out talking about each agency's background. Here are our panelists. So topic number one, can you guys describe your agency's background with hydrogen? We're going to start out with Cecil. Let's talk about AC Transit's experience with hydrogen. You guys have been in it longer than anybody. What are some of your early challenges? What's been your successes? And what are some of your plans for the future?
Yeah, thank you, Kate. So definitely AC Transit started with hydrogen back in the early 2003 timeframe. And, since then, from 1 bus to 3 buses. Then in 2010, we went up to 13 buses, which was our advanced demonstration pilot that we ran, till right now where we have 30 buses currently out on the road, deployed right now currently. Challenges early on, I'll tell you the biggest challenge was vendor support. And I say that because when we deployed our 13 bus advanced demonstration project, the support that we had from the OEMs didn't last very long. Only really was in place for about 3 years, and then they backed out of the project. And as you can imagine, that really caused a lot of concern for the agency, for the maintenance team, And then just being able to support the product. How do we keep the product on the road? So that really took the team a lot of digging into. And also, I'm going to say, is dedication to the product, right? To the technology, to ensure that we can make it work. And that leads into, the successes, right? How did we, how did we get to where we're at today? And that was the team view. And as the district, I'll call it like an all-in, meaning that everyone's lined up together. The agency itself to what the goal is, the maintenance team organization as far as, needing to work through challenges with vendors when there are no vendor support. Sometimes that was long, painstaking troubleshooting to try and figure out why the vehicle is not working properly. But then the leadership to motivate the team, to support them and what they need to be successful. Those three items really helped us to where we're at today to be leaders in hydrogen side, to continue to deploy the technology, to have the support from my team with the technology itself on the maintenance side and also with the transportation side to be successful with the technology and deploy it. Those items really helped us to where we're at today. Otherwise, if one of those was not in place or we were not aligned, I don't think we would be in the same spot that we are today without one of those pillars that were key to our success.
Absolutely. That's the kind of support super important. Let's go talk to Harman. Sunlight's been one of the early adopters of this technology. You guys have particularly invested in on-site production equipment. Can you talk a little bit about Sunlight's background with the technology and the production equipment you have on site now?
Definitely. Thanks, Kate. Yeah, so just like Cecile, we are also early adapter of hydrogen technology. We start producing our hydrogen in about early 2000. So over 20 years, we used to produce through our steam method reformer. After that, now we have a electrolyzer technology. We produce about 900 kilograms a day through electrolysis. The challenges we saw in the early stage was the industry not being so commercialized. We are seeing more commercialized and cohesive industry right now. It goes both for the fleet and for the infrastructure. It was a long wait for this day to come to talk this much hydrogen. Prior to this, there was not too much engagement. A lot of transit agencies, when the ICT plan rolled over, the battery was the way to go about 2 years ago. I think the transit industry is changing right now. I think the most critical factor in our success in hydrogen is the internal champions. I think if any industry is starting new, just develop your internal champions, develop your staff. It starts from the top management level to the executive level, but also onto the mechanic level, onto the technicians level. If you embrace internal champions, it's going to help a lot. It will have left the dependence on the technology company, so we can be a little bit of self-sustained.
Thank you. Let's turn it over to Stacy to talk a little bit about Linde's role as a hydrogen supplier and equipment provider of these programs. How do you support agencies that might be just starting out, and how does this look differently as the program scales up over time?
Good question. So as John mentioned, Linde is a global industrial gas supplier. We've been around serving the market now for 143 years. We have been in large scale bulk hydrogen production for a little over 60 now. So we do provide a full value chain of solutions to the market, and that's everything from production, distribution, storage, vehicle fueling technology for all different types of zero emission vehicles in the mobility market. Today, Linde has over 220 hydrogen fueling stations on the ground across the globe. So we bring a lot of experience to the table. And what we really try and do to support new entrants into the marketplace, or people who have, maybe they entered, they're having a few problems, is really helping them understand, what's the latest and greatest technology today? What's out there? What kind of footprints do you need? Have you thought about setbacks, safety considerations, truck access? You got to make sure that vehicle can get in there to bring the gas or the liquid or whatever you use, power requirements. And I think it's really, really critical that if you're considering bringing hydrogen fuel cell vehicles into your fleet, that you really understand the near term and the long-term business objective, because that's really going to help define what's going to work for you in the long term, because there's certainly some economic trade-offs, with the available technology. Do you select liquid? Do you select gas? And so as you scale, there's a balance of, how do you get the most bang for your buck, how do you, and all the bells and the whistles that you want in that long-term station.
Thanks so much. That's an awesome lead into our next topic, which is going to get into a bit more nitty-gritty of the economics. So we're going to talk a bit more about operating experience and fueling and fuel supplies. For Cecil and Harmon, in terms of cost, how does hydrogen stack up against the other fuel technologies in your existing fleet? Both of you, Sunlight and AC Transit, are operating mixed fleets right now. Do you see those costs decreasing, or have you seen costs come down over the past few years that you've been running it?
So if you want, Harmon, I'll go first. So definitely, cost has, gone, I'm going to say the opposite way, but definitely, we as a industry or a nation, we've had challenges right over the last couple of years with COVID and everything else happening across. So we have seen, our hydrogen cost has gone up. And I think that's part of also the supply, right? We need more suppliers producing more hydrogen so that there is, one, competition, two, larger supply of hydrogen for everyone else that's going to jump on the hydrogen market, for buses when it comes to that. So that's an item that definitely, is at the forefront for me, to keep track of our fuel prices, how things are going, what's affecting the fuel prices that's driving some of the costs, that's a big item for us. And then, operations, when it comes to that, the other items in our facility here, on the hydrogen are pretty, when I look at it, our infrastructure costs is very similar to, like a CNG cost, so I have normal maintenance costs that come into play there. So that is very relatable when it comes to that, when I'm looking at those operating costs. But fueling in my aspect for the team here, it is an item that we're trying to definitely keep an eye, and we are hoping and as more agencies go into hydrogen and more buses are deployed across the US, that we definitely know that there are suppliers that are bringing stations online, more stations being built. I look forward to seeing hydrogen come down. I need to see hydrogen roughly right around $5 a range. That'd be really is the CPM ballpark for my operation to be a parity with diesel for my diesel fleet. So that's what I'm hoping to. If we can get under that level, but it's even better, so that's a challenge out there.
Yeah, 5 is really the magic number for natural gas and diesel. Yeah, go ahead, Harmon.
Sure. I think very much in line with what Cecile said. On the production side, I think there's a lot of dependency on the utilities. So what your utility agency is, your power needs, your water needs, if you're doing through electrolyzer, plays an important role. And we need to understand how utility works. So that's another area where I think the agencies need to put emphasis. A lot of utility agencies are different. Some are time of use, some are the peak demand. So that all comes to play when the production is happening. Most of the production happens at the nighttime here. Which sometimes is where we are. It's the peak demand time. So obviously, the more work with the utilities on production side, especially like the small production for a transit agency, I'm talking about like 600 to 900 kilograms a day, plays an important role. On the rolling stock side, on the buses side, yes, we have seen in last 7-10 years, R&D buses being more commercialized, and now the fuel cell buses, battery electric buses, and CNG buses are kind of in line. They're still expensive, but they're comparable. 5-6 years ago, those were not comparable because they were not available commercially. So yes, definitely on the rolling stock, it's comparable. On the production side, it differs where you are, what your utility companies are, how expensive your power are, and what technology you're using.
Okay, just to add on it too, because we're talking about the rolling stock and just the fuel prices themselves, right? But Another important item, and Harbin, you could probably touch up because you have a different system. And I purchase fuel, store it, and then fuel my vehicles, right? More, I'd say, similar to a diesel operation that everybody might be familiar with, or a natural gas operation. Well, Harmon actually produces fuel on site, so he has a whole different aspect of infrastructure when it comes to that. But in my scenario of my infrastructure cost, scalability is an item that I always look at when it comes to the fuel. And John talked a little about the changes. Why did we go from a 30% hydrogen, 70% electric, and the changes when it comes to that? And some of that has to do with just touch up a little bit on the infrastructure costs, right? That overall cost that you look at. So we can build a hydrogen infrastructure for 150 buses for roughly $8 to $9 million, and I'm pretty much having my whole facility done. Don't ever have to do any other upgrades, and just buy buses going forward. So that's an item that, as an agency, we're looking at the funding that's available right now, build my infrastructure so that it is set for the future years, and I don't have to go back in and really tear up the ground, the parking lots, to add other expansions. We're really moved into a phase from pilot to full-scale deployment, build the infrastructure one time, build the pads to expand to multiple pumps or extra tanks. So that way we have minimal interruption that we may need to do when we go to increase our capacity across our divisions.
Yeah, thanks for adding that. That's really good information. Stacy, from a provider's perspective, what does that startup scale up really look like for a hydrogen operation? Say you're scaling, you start with your 10 bus pilot with today's technology, and then you're scaling up to 150 to 200 bus operation. And feel free to jump in, Cecil or Mark, if you have things to add.
I think Cecil made some really good points. He really nailed it on a lot of things that you need to think about. So, I can't overstate, kind of understanding where you are initially and where you want to go with it, because, certainly the trade-offs can have a large economic impact. So if you're looking at, the smaller end of the scale and you're talking about 10, maybe smaller, small use points where gas is near where you're going to be located. Maybe you want to spend a little bit less on capital. You're willing to pay a little bit more for the gas. Maybe that's what you need. If you're thinking about taking that next step and scaling to 50 to 200 buses, you need to ask yourself, is a smaller standalone solution, is that the right solution today? Do I need something more modular that I can scale tomorrow and, add that concrete today so there's space for the tanks, the pumps, whatever you may need to add? Because liquid, very quickly becomes the more economical solution when it comes to some of these technology and when it comes to scale. So, it's important to know your end goal. Are you willing to put, a little bit more capital on the ground today, pay less for your fuel? Really in the long term, is that really what makes the best sense for your operation? And I think that's really, really important when you talk about scale to understand.
Let's talk a little bit about fuel deliveries for you, Cecil. How regularly do you receive fuel deliveries for your existing fleet, and have you struggled any with service interruptions?
Yeah, sure, not a problem. So I have two facilities that have hydrogen. One facility has a 15,000 gallon tank and the other one has a 9,000 gallon tank. Typically we see deliveries once a week, for the facility. So, very, normal deliveries, I guess that I would call it. In the years that we've had hydrogen, almost 2 decades of, the piloting, actual divisions with 2 hydrogen infrastructures, we've never had a shortage of fuel. I'm happy to report. I can't say that we've never had notices of force majeure, but that's only been 3 in 20 years, roughly, so I think that's pretty good. But I've never had a shortage of fuel. We have, I'm going to say collaborated to just, what we did strategically when we did receive one of those force majeures is Instead of operating the fleet 7 days a week, we just changed to operating it 5 days a week, just to reduce some of the consumption, just to help out the vendors, so that we, made a good conscious decision to do that. And at the end, I'll say that it wasn't necessary in there, but we wanted to do our part just to ensure that everything that we could help out the vendor as much as possible and be partners in the process. So we've never had an issue having hydrogen supply for my fleet.
Awesome. And then let's talk to Harman a little bit more about your fuel fueling infrastructure. So you started out with SMR. You still have it on site, or are you just purely electrolysis? And you have a cost comparison between technologies for your existing utility?
Yes, I think you were cutting off, but if I understand your question, you're asking about the fuel infrastructure, right? From SMR all the way to where we are right now, right? So just to give some background, when we started our SMR, our production was about 170 kilograms a day, which was good at that time. We had 3-4 buses we start adding. The production we are having with electrolyzer is 900 kilograms a day, which is on an average, if you fuel 30 kilograms in each bus, you can fuel up to 30 buses. The challenges we are having is what we have seen on electrolyzer technology is the fuel stacks are good. The production of hydrogen and storing at low pressure is easy. Where we see some challenges is on the compression side. When you compress the gaseous and chilling it, that's where you see a little bit of challenge with the compressors or the O-rings and everything. But what we have seen a really reliable production through these electrolyzer. So that's where we have seen. We're also doing an R&D project with SoCal Gas to produce, hydrogen through a STARS unit. The goal is to, ideal goal is to have hydrogen through SMR under $5. We are using our old system, our old compressor and old storage to do that. That's in the commissioning stage. So we are very excited because it's a really small footprint to produce hydrogen through SMR. However, in the state of California, we have some other challenges. Another infrastructure project that is coming to us is actually, we're happy to share that we're also developing a liquid hydrogen station. We have 30% drying reviews. We have selected a contractor. It's going to be a 15,000 gallon liquid storage, which is about 4,000 kilogram gaseous. And then we will have 2 dispensers behind the fence, both 350 and 700 bar, and 1 dispenser for public fueling, which will be both 700 and 350 bar. So that project should be ready and should be commissioned within the next 14 to 18 months.
Oh, that's really cool. Okay, we might have to ask a little bit more about that in a minute. And then let's talk about production facilities with Stacy. Where are production facilities in the US for those people purchasing gas? And how do you see production scaling up over a 5-year time horizon? Let's talk a little bit about the DOE hydrogen hubs and about how do you expect costs to decrease over time?
Okay, I think I caught all of it, Kate. You're really, you're kind of fading out. There's a lot of layers to that question. So I'll do my best because I think I could probably talk on those topics for probably the next hour. Okay, so let's talk about supply first. So Linde itself has 5 liquefiers across the US today. And so it gives you coast to coast coverage, but that's roughly half of the production in the US today. Hydrogen supply in the whole US, is fairly limited, with the total capacity being only in the neighborhood of about 300 tons per day. So while I think, we're going to be able to support all these initial deployments or vehicles coming out, I think you're really not going to start seeing that significant scaling occur for about 5 to 10 years when you start seeing these DOE hydrogen hubs come into place, and some of these mega scale projects that are in the works, finally get done. Those are very complex projects, and they're going to take us a little while. From a cost perspective, there are a number of drivers that go into this. You have cost of utilities, your cost of new capital, cost of local distribution, available incentives, the T's and C's of your contracts, they're going to impact them as well. So production costs today, they're being mitigated through the bipartisan infrastructure law, the production tax credit. And I think this has really helped driving down the cost of production to make this larger scale feasible and, more importantly, more sustainable. But the variability in the cost stack and the things that we have control over, I think it makes it really difficult to predict, how that's going to impact, what you're going to see at the pump. That's a difficult translation to make.
So can you guys hear me all right?
A little better.
Okay. So we don't know how exactly it'll affect. So the $5 a kilogram mark is for larger scale, is at least 5 to 10 years out.
I think we need to see scale. Scale is what is going to drive it down. And like I said, we see these pockets of development in, the fueling stations in Southern California, the new pockets of production. I think everybody's working together, the OEMs, the fuel suppliers, the station developers, everybody's working together to keep building out these pockets while we work to that next step, which really are those hubs. But that, like I said, that's a little ways out. And I think that's when you're going to start seeing, when we make some serious headway between where we're at today and, that, the critical, the total build out of infrastructure tomorrow. I think we'll make some real headway once we see those hubs come online and those really large scale plants. So while, the infrastructure law, the production tax credit, it is certainly helping, but there's so many elements that have so much variability that we don't have control over. And I think, utilities is a good example of those. There's a lot of variability in natural gas pricing, a lot of spikes, a lot of availability of power, a lot of things we can't control that we just have to navigate, I guess. So will those things start to smooth out over time? I absolutely think so. I think we will get there. I think we have to kind of ride out some of these bumps, though, in the beginning. But it's certainly, with what we have in place today and where we're going, I think that's a very realistic target. And I think we will definitely get there in the near future.
Awesome. Okay, moving through to question 3, which is, what advice would you have to an agency considering piloting a hydrogen fleet? So turning it over to Cecil and Harmon, what were some challenges your agency faced in adopting this new technology, and how did you work to overcome them? That's, specifically speaking to some of the maintenance and operational impact on your fleet.
Harmon, you want to go first?
Yeah, I can take first. Thanks, Cecil. So I start with the challenges that we faced when we was delivering the project. So our fueling station, with the electrolyzer, one of the lessons learned is that we needed 2 megawatt of power to run the electrolyzer, and when we were doing the programming of it, we realized that we have to bring that power. So to bring the power to the electrolyzer cost us about over $1 million. So the first lesson learned is that if you're going into hydrogen technology or in battery electric technology for production or for charging, make sure you talk to your utility companies. See how much power you have. I always say that do a master plan, like do an audit of your division or your yard. How much power you have right now? How much power does your substation has? If you need extra power, is that substation okay to give you that power? So that was one of the first learned lesson, is that utility integration is very important and at earlier stage. The second thing that we challenged during the maintenance and all is that is just this workforce training. I think we need to have more workforce training so that way we can day-to-day operations and the PMs and other stuff can be taken in-house. But on dispensing side or operation, I think the continuous education of the operators also, because these buses, this technology, the mileage and everything is depend how you drive or how you operate these vehicles too. So that's another challenge we can overcome is by just training. It's just training is very critical, both on the production, taking care of the equipment side, and both on the operation side when it comes to operators.
So for AC Transit, I want to go back to one of the things that Harmon said on one of his earlier, and that was the champions, right? So when you're deploying this new technology, whatever technology it is you definitely have to have those champions in maintenance. I'm going to say it in that aspect because just like you set up the trainers, those champions are going to be there to guide and promote the technology, help any of the other maintenance employees that have questions or not sure. But you want to be able to talk it up, and it's not just because it needs it, but you need people there that are, and for maintenance folks, we're there 24 hours, right? We have teams there mostly at nighttime taking care of repairs and maintenance. So it's important that you have folks that someone can go to during the nighttime if there's a question for the technology. So that way the vehicle just doesn't sit there and become stale. The repair that may be needed or the task, if it's a preventive maintenance. So for us, it was very important to have those champions within our maintenance department and also in the operations side that enjoy driving the vehicle, that like the technology and want to talk it up and promote that to other transportation employees. So that was very important, that is very important when you're looking at deploying the technology. Workforce development, when I think about it, it was back 2010 when we got the 13 Van Hools that we had. And that was really where we had to look at the deployment of training and how do we kind of scale up a little bit more with the training and really get down and dirty into the repairs. And we had to do that by no choice, meaning because we had no support. As I mentioned, the vendors, OEMs, basically left that technology and moved on to something else. So we had to, look at kind of creating our pathway when it came to that. That is why we are where we're at. But when it comes to that, I'd say for other agencies looking looking to deploy this technology is make sure you understand, that training aspect. So one, don't overthink it. We pretty went back to simplify it. We use everyone in the maintenance industry uses a technician to bus ratio. That's just, you go back to the basics. The same setup is what you should be using to scale up. And I use that right now as I go to purchase 30 more buses. Okay, how many more technicians do I need to get prepared to make sure they're ready for those vehicles? And I do that for each one of my divisions so that I have a team there ready to accept those buses. The great thing is buses aren't on the shelf, right? When I'm looking to purchase a bus, I have about if I'm lucky, 12 months, but most likely it's usually about 18 months before I see a bus. So there is a time frame that is going to be there to train those mechanics, get them involved with the process so that when your vehicles are received, you have staff trained to be able to accept those vehicles. Even with our programs, we do a lot of OEM training programs, basic trainings, but we also do all our advanced training that is done in-house with our training centers. So having trainers, having teams that are familiarized with the technology, reach out to other agencies that deploy the technology, visit the sites, see what they do. I mean, always, don't ask questions. There's, Sunline, us, other agencies that are early adopters of the technology that we can definitely let you know what we went through. And then you can look at how you can apply that for your own agency, your environment, I'm going to say politics, because sometimes that's something that is very important when it comes to your union, right? That's an item that is very important that you reach to that stakeholder of the union to bring them on board so that they understand the technology. Because the number one item was the fear of, I'm going to say electrocution, but just the fear of working with the technology. Just when we deployed going from diesel, let's say, to CNG, you have that unknown fear, of the high pressures, and so there's the fears of with hybrid technology and the high voltage. So getting those fears out of the way, getting your team familiarized with these items ahead of time. And it might be in phases, little by little, versus just dropping a whole book on them, say, hey, here's the vehicle, now you need to go learn this technology. Then you're going to get a shock factor with the team. Feed them in small pieces, the technology, and just lay out that plan on what you're going to do.
Thanks so much. So final question on our list is for all three of you. You've answered most of it. What are your key considerations for setting up your hydrogen operations in terms of infrastructure, specifically space and fire code restrictions. And I know both AC Transit and Sunline have done a lot of design work to get fueling stuff on site. And of course, Stacey's working on citing all of these equipment pieces all the time. So speak to a little bit of the space requirements for each of these.
So I think, you know, if I left you with any piece of advice today for anyone unfamiliar with hydrogen, definitely seek out experts in the industry and educate yourself on what's available today. Because, you know, not only the other things that we kind of touched on, which is, you know, understanding your business objectives and the technology available. Technology itself in the last few years alone has evolved a lot. You know, there are a lot of small and medium scale solutions today that didn't exist a couple days ago. So understanding how those may look and fit in to your facility, understanding your expectations around fueling rate, what you want the system to do. Is it a good mix? Do I have the footprint available? Can I get a full-size tractor trailer in and out to take care of it? You know, and aside from those things, you know, there are some differences in distances and setbacks between gas and liquid. There are different permitting requirements. I would definitely suggest that you get to know your local fire marshal. I think that is a super important relationship to understand for permitting. What are their views? Do they have any concerns? Because you know, different fire marshals have different views on what they think the concerns are, how they like to approach those concerns. So really important. Certainly a good relationship, you know, with neighbors around you to understand, you know, the community impact. If they see hydrogen coming into the neighborhood, you know, having good relations and having your suppliers help, you know, work and kind of that community outreach to help make everybody in the neighborhood comfortable. Asking yourself, what are my needs versus my wants when it comes to this project and it comes to scale, and are they all going to mesh considering, you know, this is my budget? Do you need O&M services? Do you plan on, you know, do you have a staff who can handle it? Do you want to contract your O&M services? And if so, is it, you know, how long is that O&M available? Is it for the life of the equipment? Is it for a small, you know, piece? You know, maybe the first couple of years, really important to know, you know, all those things together. And so I think there isn't a supplier I know who wouldn't love to just, you know, get on the phone, come visit and talk a little bit about, in a little bit more detail about all the things that you need to consider to avoid some of the pitfalls of, you know, early adoption when, you know, we didn't know all these things that we know today.
I can, if I make it, I can share our, you know, as far as the city permit, the code. So we demonstrated a pilot project at Sunline in October 2021 to February 2024. It was a trailer. It was a nice trailer. It was a liquid, delivered liquid, vaporize it, and a dispenser. So we went to the city, and you know, it's just basic permit with the fire department and everything, some steel plates so that the delivery of liquid can happen. And it was just like a little over like $25,000 of infrastructure cost to run the conduit. We did this pilot for about 4 months. We fueled about 300 buses there. You know, we dispensed about 6,000 kilograms of fuel. So as far as permitting is concerned, I think the technology is ready. As Stacy said, you know, fire marshal, you know, knowing them, educating them early is very critical. That's why I was saying, you know, if you're thinking about going hydrogen, bring all the partners on the table. If you're in a county, unincorporated county, bring them on the table, bring fire department, utility companies. It's hard, but it's very easy to educate them at front as you are developing your project rather than afterwards, because their input, you know, all project depends on their input and you know, subject to the certificates of occupancy or to operate there.
So Harman hit an item, you know, bringing everybody to the table. For us, success was having the fire marshal part of our project team. So our permitting process was flawless when it comes to that because his name was on the paperwork. So as things went through and any changes, if he had a comment or right there, then the engineering team was able to provide solutions quickly. And one, it also saved us costs, right? Then having documents done and then we have to go back and redo everything. So at least there was questions were answered up front. Solutions were provided right away to be able to solve those things. So if you could get your fire marshal or somebody from that team to be part of your project team, hands down, probably the best thing you could probably do when it comes to the hydrogen technology and getting infrastructure built at your site. The other item that I'm going to say is scaling up. So for us, we've learned that, one liquid cryogenic pump to one dispenser can give you 65 buses. Basically, you can fuel 65 buses in a fueling window. So when you consider whatever your fleet size may be, those are kind of what you're looking at when it comes to the technology and what you deploy. That's what I have currently with my fleet. And space constraints, we all have space constraints in transit agencies or probably any transportation company when it comes to that. But if you run natural gas right now and you have a natural gas station, your footprint will be very similar to that of a natural gas station, a CNG station or LNG station. You're going to see all the same components that you see in the infrastructure of a CNG, LNG station. You're going to see in a hydrogen, no difference. And also the cost that you pay for maintenance when it comes to that should be it's in line with what you see when it comes to that. So your footprint, you can gauge that roughly of what that would require based on your fleet size. But I would say is if you're looking to deploy, try and get your outlook on what it is that you're going to do. Meaning, is it hydrogen? Like for us, we're going 70% hydrogen. So I can put numbers of how many of my vehicles do I expect to put in a hydrogen technology, make that investment now into that process, and just make sure you ensure for scaling up. Make those infrastructure build outs right now. Take advantage of the funding that's available right now. So that's an important item, right? We don't know how long this funding is going to be there. So maximize the benefits that we currently have under the infrastructure bill, and to deploy the technology that we are being asked to put out on the road for the future. So that is my advice that I'd say that because we did early on for us, it's a learning lessons. We scaled up and small deployment, small infrastructure, and we've done all the piloting. And I would say is don't be afraid, to build your infrastructure. There's a lot of agencies, we've done the piloting for a lot of this stuff. I know that a lot of us like to do our own thing, which is fine in there, but if you can take a look at the numbers that match to your scenario, it would be in the cost benefit that there's no reason to do an infrastructure, a smaller pilot. You could do a build out from different vendors to get your hydrogen solution or supply delivered, and then do your trial based on that, and then go into a full infrastructure build out based on what your plan is for your ZEB rollout plan, basically in that scenario. So I think that's one of the answers, because we spend a lot of money with the different technologies and trying to maximize our space, our footprint. And at the end, hydrogen does meet a lot more of our needs when it comes to what my fleet can do and how I deploy my fleet to my current diesel layouts that I have right now.
All right, thank you guys. That's the end of our programmed questions. We've got a few extra minutes. So I was going to get into some of the questions our participants asked, and then maybe we can, as we have time, we can dive in a little bit more into details to some of the points we talked about earlier in the webinar. So first question I had, the range has been answered. Was it a little bit on fuel range or bus range? How much mileage are you really getting out of your vehicles? And has it impacted your operations at all?
So our vehicles, so I currently have 30 new flyers that are battery dominant buses, have an 85 kilowatt fuel cell, 100 kilowatt battery pack, 37 kilograms of hydrogen on board. That gets me 300 miles, 300 miles to empty. So typically I deploy those buses no more usually than 250 miles, and I'll call it that sight unseen. My climate is usually about 70 degrees, so pretty nice climate, I'm gonna say, overall, ambient temperatures type. So that gives you a range, I'm more than comfortable deploying the bus at, the 240 to 250 range, and never having to look at the bus on a daily basis to what's happening with the vehicle.
And on our side, we have the same, new flight Excelsior, the 85 kilowatt fuel cell, 36 kilograms of hydrogen, and the other fleet is CNG we have, so there's like one-to-one replacement. So all our routes which were managed by CNG has been taken care of by fuel cell. So we don't see any reduction in the routes or any compromise. We do see reduction in mileage in our summer days. When we are over 115, 117, yes, there is both battery electric and hydrogen fuel cell. We see some challenges with CNG also because of the higher air conditioning use and the doors open and close. But overall, the mileage of a fuel cell bus is a better mileage than a CNG.
Yeah, absolutely. Another question for our transit agencies is about reliability. How's your reliability been? Is it more reliable than your battery electric buses that you have currently?
Well, that is that's like the $1 million question about the technologies, right? Definitely, we see issues with both technologies, to be honest. One of the things to keep in mind is that a fuel cell bus also has batteries. So there are a little bit more components on a fuel cell than when it comes to a battery electric bus. In our experience, our fuel cell buses have been more reliable than our battery electric fleet has been. And I will caveat to that because the number one problem we see with either technology is a battery issue. I tend to have something with a battery string problem, a BMS, some kind of correlation related to the battery system. So that tends to plague both buses. But when it comes to the fuel cell itself, typically don't really have any problems when it comes to it. So, but our experience has been that my numbers in reliability and availability for the technology, fuel cell has performed much better than our battery electric bus has. That's our experience.
Very, very similar. The challenges that we have in our buses are not the technology challenges, as Cecil is saying. It's not like the fuel cell challenges. The challenges are the downtime is just like any other bus, ramp not working or some other preventive maintenance or something. But in previous one, if I go back to like second or third generation with Eldorados, yes, there were some challenges in the integration or into the fuel cell itself. But I think we can safely say that fuel cells have matured enough to have it compared to any other technology bus.
Awesome. Question about fuel cost. What are your current costs per kilogram, and what are you budgeting the next few years?
So I buy fuel, of course. So I think maybe that'd probably be the easiest one to answer that question. So I buy fuel, store it, and put it into my vehicle. So just like it was diesel, right? I don't have any O&M costs associated with my hydrogen costs. My current hydrogen cost is at $9.04 a kilogram.
I think for us, when we were producing through SMR, we were averaging about $6 a kilogram. However, the production was only 175 kilograms daily, back in the days. For electrolyzer, it varies. We have a lot of demand charge and everything. So I would say our sweet spot for hydrogen production is anywhere from $12 to $14 a kilogram, would be a good one to say. The one when we had for our liquid hydrogen station, we did get a proposal that's about $10 to $11 a kilogram, but that's still 18 months from now, and we can still renegotiate on that at that time once the liquid hydrogen station is up.
Okay, we don't tend to have a ton more questions from the audience right this second, but I have a few questions for you guys based on some of the topics we hit on during this chat. So for Stacy, I wondered if you could talk a little bit more about the O&M for your on-site. Oh, do we have more in the chat? Let's open up this guy. Here we go. We have, does Lindy have support and or hydrogen infrastructure in the Southeast Florida area?
Okay, yes. So Lindy has 5 liquefiers across the US that really, give me coast to coast coverage. Liquid, it's pretty economical to move it around the country. So yes, we have it on both coasts. We have it in between, so that we do provide quite a bit into Florida right now.
Fantastic. Thanks. Oops.
I do have a question for both Cecil and Harmon. What's the public reaction to the hydrogen buses? Is it just a bus, or is there a positive reaction? What do the riders think? How's the public reaction to zero emission and fuel cell?
Oh,
Go ahead, Armin.
Go ahead, Jason. So I think first of all, end of the day, we are bus companies. Our goal is to transport people on time. That's primarily we are known for. I think overall reaction for public, I think first of all, our board is on board. That the governing board are very much, they are representative of public, and they are very supportive of our technologies. So that's like the first victory. Overall, at the public, we do see comments. They are very quiet buses. If you haven't been into a battery fuel cell bus, you can hear a conversation. These are very super quiet buses. Compared to CNG and diesel, and we do get comments here and there. A lot of outreach we do that also helps. So a strong marketing department can help also in this space. Just to spread word on the social media and other platforms that we have. Nothing's. I would say it's just like the more outreach and information you provide them is better. But having these buses on the road, general reaction is always good.
So being located in the Bay Area, very political area, a lot of folks that support, the conversion and reduction of greenhouse gases in our environment. For us, any of our zero emission technology buses, when I deploy them, is very favorable and receive a lot of praise. And part of that is because we deploy all our zero emission technology buses in disadvantaged communities. That is our highest priority. So all my vehicles that come in, that's where I put them out on the road. I put them to the most critical and needed areas of our service areas. And for that reason, we get a lot of praise, a lot of support from the local legislative when it comes to that. And it's a great benefit. We can impact multiple communities and impact many targets strategic plan that the district has.
That's awesome. Question from participant: why is hydrogen fuel measured in metric units and not English units? Will there be a trend to go for English units? I, as an engineer, love this question. Go ahead, Steve.
That's a really good question. You know what? I just got to go with the flow. I find even when I'm talking with the folks in Europe, we talk about tons per day, and we typically talk about metric tons, but, we could talk about short tons. In most of the conversation in the US, we talk about kilograms. I don't know. That just seems to be universally, that's how we talk about the different quantities. That's a great question. That makes me laugh. I don't know.
Yeah, I'm going to add a tidbit for anyone looking at this technology. I've sat in the shoes of where Cecil and Harmon are, and you really need to learn the language and the metrics that are used in your industry. So if you're looking into hydrogen, you do need to start understanding, I always think of a kilogram of hydrogen having about the energy equivalence of a gallon of gasoline. And that's rough. Kate will kick me in the shins for saying that, but you need to start learning the language and the metrics. And ultimately, you need to boil it down to a cost per mile or cost per kilometer. It works out the same way. But all your fuel types here, you need to be able to compare on a like-for-like basis. And the best way to do that is ultimately a cost per mile.
Yeah, cost per mile is a super important metric, and I would use that. In terms of kilograms and using the metric system, I think it's really convenient to use the metric system when you're talking about a compressible gas. So, AC Transit has a 9,000 and I think a 15,000 gallon tank. Well, how big is a gallon of hydrogen? Will really depend on the pressure to which you compress it to. Are you compressing it to a gas or a liquid? So using a kilogram measurement or using a weight measurement is really important when you talk about the quantity of a gas. Another question, how has AC Transit managed a 90% availability of its station versus retail stations in California only operating at 60% availability?
I was gonna say that's a typo. No, not kidding. No, honestly, there is resiliency. It's actually the reason why our station has such a high number. So at all my two divisions that I have hydrogen infrastructure, we built in resiliency. We have 2 pumps, 2 dispensers. So if one goes down, we have the other one up. So that that availability is a factor of me being able to fill my vehicles in order to go out to service. So if one of my pumps or dispenser goes out, I can turn on the other one and I'm still able to basically put vehicles out in for service. So it has to do with the way our stations were built for reliability and availability. I will say that in the 15 years, or at least in the 10 years that those 2 stations have been built, there's only been about probably 3 to 4 times where I've had to move buses from one division to another because I could not fuel at that division because of something severe, that there was a infrastructure issue that I could not fuel at all. So the system has been very reliable, but definitely we built in parameters for resiliency to ensure that we had the utmost availability to provide the service to the public.
Thanks so much. Thanks everybody. That's about all the questions we have time for. I'm sorry if we didn't get to you. Feel free to shoot us a message and we'll connect you to everyone offline.
No, thank you everybody. Great webinar here. Stacy, Cecil, Harmon, you guys are awesome. And by all means, if there are questions, reach back to Kate or myself. I know we're in the emails and the notices here. Be more than happy to work with anyone looking or considering hydrogen options for their fleet. With that, thank you so much.
Thank you.
Thanks, everybody.
Thank you.
Thank you.